When it comes to dividing monomials, I want you to look at these problems in two different ways. First, I want to separate out the problems where we divide by a monomial. When there is just a single term in the denominator, I want you to create separate fractions. I want the 10x to the fourth y to the third to be divided by the 10x squared y to the ninth. And then separately, I want the 15x squared y to the eighth to be divided by the 10x squared y to the ninth. We know this can be done because whenever you add fractions, you keep that common denominator, and these add together to make what you have at the left there. I'm just splitting this apart into two separate fractions. Then we're just going to reduce each of these. When we reduce the first fraction, the 10's just cancel. With the x's, there are two extra x's upstairs in the numerator when we divide. And with the y's, we get extras down below. 9 minus 3 is 6. So we have y to the sixth down below. For the second fraction, 15 over 10 reduces, dividing by 5, into 3 halves. The x's cancel all together. And with the y's, there's one extra y down in the denominator at the end there. And so that would be our answer to this division problem. In problem number 2, also dividing by a monomial, I suggest we just take this and write each term over here at the left over that 4xy to the eighth. And then you've got 3 separate fractions, each of which will be simplified as we did in the problem above. So in the first fraction, 8 over 4 reduces to 2. With the x's, there are 2 extra up in the numerator, and with the y's, we have 7 extra down in the denominator. It's bottom heavy, so to speak. We have a minus sign between our two fractions. In the next fraction, the 4's cancel all together. With the x's, upon subtracting, we have 6 left over in the numerator. And with the y's, there are more down below. There are 3 more down below, so over y cubed. Plus, third fraction, the 2/4 will reduce to 1/2. I'm not going to write the 1 upstairs there unless I need it. With the x's, there's 2 upstairs and 1 in the denominator, and they'll cancel, just giving you 1x upstairs. I don't need the 1 there anymore, so I'm glad I didn't write it. And with the y's, there are 4 extras down below, so there will be a 2y to the fourth in the denominator. Now, this process has been for dividing by a monomial. Whenever you don't have a monomial, a binomial or beyond, that's when you have to use long division. So before we move into it with the algebra, I want to make sure we know how to do it without the algebra. So we would take our 512, divide it by the 31. We'd begin by asking how many times did 31 go into 5? It doesn't. 31, how many times does it go into 51? The answer is 1 time. We take the 1 on the top, we multiply it by the 31 on the left to get 31, and then we subtract and we get 20. We bring down our 2. We try and figure out how many times the 31 goes into the 202. We guess that our answer is 6. 6 times 31 is 186. Subtract and get 16, which is our remainder. And I'm going to write that as plus 16 over the 31 we divided by. Now, the way we would check our answer, the opposite of division is multiplication. The check would be to take the 31 on the left, multiply it by the 16 on the top, add 16 to that, and see if we get to the 512. In other words, 31 times that 16 plus the other 16 should get you to the 512. Now that's important for us when it comes to checking the division we're going to be doing in a moment.